Hey, so today I'm going to be talking about Kiji and Scalding and how I use Kiji as the easy way to get started with data science at scale. First of all, I wanted to tell you what Kiji is. Kiji is a modular and open source framework for collecting, analyzing, and serving entity-centric data in real time. So that means that you can use your NoSQL systems and build out big data applications that can serve out things in real time. These could be recommender systems. These could be a lot of different systems. But I'm going to focus on another aspect of Kiji where we can use it to really start doing data science on big data. And I wanted to thank Vitaly and Sasha, who earlier yesterday and today have been talking about using Scalding at LinkedIn. And yeah. So Kiji's history. Kiji comes out of using Avro and HBase and Hadoop, and now recently we've been adding Cassandra. Kiji combines all of these things and wraps them together in a way that you can build out big data applications. So today I'm going to be talking about the motivation that I've touched on. The big theme of my talk is that it's easy. I'm going to take a brief data detour on our data model and how you use Kiji Express to start doing data science, and then how you can start working with it locally and then bring it out to your cluster in the cloud. So in terms of motivation, sort of the prototypical example that we work on often at WibiData is, customers who bought bananas might also be interested in carrots or bread or milk. And one of the interesting things about Kiji is that at the heart, it's a system for storing knowledge and data about your specific entities. So, in this case, it might be, we'd be talking about this customer who's coming over here and what she's bought. So, before, we were in a system where I would have big logs with lots of data, and we'd be engineers kind of trying to process that data, maybe put it into MySQL. And then we'd also have data scientists who would be thinking about, okay, how do I build a big data product out of that? And we data scientists would be thinking about it in terms of tools that we use like R and Python, which work really well locally once you've downsampled your data, and really can make really cool models, but it's really hard to get them off of the laptop and onto a big data situation where it's deployed out in the cloud and can be served in a real-time production system. So I go to the Hadoop store and I pick me up a Hadoop. And that allows me to take my logs and all the stuff that I've put into my MySQL database or any other relational database, and to put it all into Hadoop. But now I've got a little bit of a problem, because running ops on Hadoop makes me scream. It's really challenging. Especially as a data scientist, I don't have the expertise in that system to really be able to do that. I'm sure that there are some folks out here who are great at that kind of DevOps and at running a Hadoop cluster, but personally, it's just too much of a challenge. And moreover, I've really found that the skill set that it takes to really set up and run a Hadoop cluster well are very different than that skill set that it takes to do that data analysis and data parsing and really build those data products. some people can be good at one, some people can be good at another, but it's a very rare person who's good at both. So then I find myself stuck as an engineer up there coding away, trying to build out my data product, and I want to build out recommendations, and so I need to get recommendations and request recommendations, and I or my data scientists have gone through and trained a model, but maybe we've used something like R, and that's not really deployable. So what am I going to put in that question mark? So it's time for some data science. I go back to the Hadoop store, and this time the sales rep gives me a free add-on Kiji. Okay. And he says, trust me, this is what you need, it's easy. And here I am up here telling you it's easy, but we've all been to talks like this where someone says, this is the solution, it's so simple to deploy, and you come, tomorrow it's Sunday, and you think, I'm going to try it out, and you start doing it, and oh my gosh, it's never that easy. Well, don't believe me, believe this guy. Antonios was kind enough to have written this book. I've never met the guy, but thanks, Antonios, if you happen to see this on the web. And if you're interested in this talk and you want to try this, buy his book. Oh yeah, I've heard it's easy before. And so at the heart of Kiji is a storage system for reasoning about your data. But how do we actually deploy it and get started? So if you just go here to our Kiji.org site, 3 easy steps, really just a click and a couple of exports and sources, and start installing your table, and you're off and running on your local laptop. So what will this set you up with? It'll set you up with your Hadoop system so that you'll be able to type Hadoop FSLS and start looking into your HDFS file system. It'll allow you to start building Kiji tables, which are, and it'll allow you to start building Kiji tables which interface with either HBase or Cassandra. You can start taking your records about your entities that might be complex objects and serialize them with Avro. And even better, you can start using Scalding to process and think about these entities, rearrange them. So for data science, we've got Hadoop analysis via Kiji Express, and that's Scala and Scalding. We've got a unified API for reading customer attributes and events. And yeah, data scientists and engineers can be friends by using this. So let's find out a little bit more about Kiji Express. So I'm going to take a brief tangent on the Kiji data model. We all know that data munging and rearranging is often the real challenge of doing data science. So how do we orient our data so that that kind of munging and rearranging can be done easily? Well, so when you start up a Kiji instance, you're going to be making a table, and those tables are going to have rows in them. Those rows are going to be focused around an entity. So the key in those rows are going to be your entity ID, and then about those rows we're going to have data. Nothing new here. So one of the cool things that you can, where it starts getting a little bit interesting, is that in your entity ID you can have a composite entity ID, where part of it is some hex code that keeps it all unique and keeps all those nice database properties, but you can also add in your own entity ID that describes your data. In this case, it's Bob. And in addition, we can have column families that will separate out different types of different types of columns that may have different meaning about your data. And in addition, so even within those, we can start separating them out where, you might have in payments, you might have both a card number and an address, or you might have, with interaction, you might have both clicks and searches, things like that. And in addition, what's even cooler is that you don't have to have just one of these. So now if you have clicks, you can record every click, and that's all associated with a single row, so that when you want to go get our information about Bob, you can get all of the clicks that are associated with Bob. And at the same time, you can look at all the different sets of recommendations. So you can see where this would be really useful, because with a single database query, you can get all of your data about this single entity, and now you can sort of deal with this data that's effectively in n dimensions. So in summary about this data model, Kiji is entity-centric, and we have an entity ID as the primary key. It encourages using wide, flat rows to encapsulate all your information, and it also, one of the things that I like about it for data science is that it encourages setting up your data in a way that you can easily get tidy data, which is a concept that you'll often hear from statisticians. So data science with Kiji Express. Kiji works really well with Scalding. Kiji Express is written in Scala. It has all of your Scalding goodness, which is like your flat maps, your filters, your groups, reduces, joins, and it's you can really, because you have all of this, you can express complicated flows of these map-reduce jobs through a simple Scala-based DSL. So this is very much where we come back to the kinds of Scalding usefulness that our two friends from LinkedIn talked about. And remember that it's still functional like Scala, and you have all your relational algebra primitives. So let me give you just one slide of code. A lightning talk is too quick to actually go into code. But up here, it looks like normal Scala code. It's really pretty easy. What we've got going on here is just a simple class where we've pulled some information out of a database. We start doing a filter on it. We start doing a flat map 2 on it and a group by, and then take the size. So nothing especially interesting going on here. In the dots, I edited that out, but we could easily send it down either back into a different column of the database, or we could easily send it out to a text file, CSV, whatever you want. So data science benefits beyond Scalding. You can work on ML models. You can build out cosine, TF-IDF. There's a lot of cool data science that you can do in order to build out different data products out of this data once you have once you have it arranged this way. You've got simple APIs, and you have Avro records for all your POJO needs. So I told you I was going to make it easy to go to the cluster. So now I've got a Kiji on my laptop. It's working by installing Bento Box. I have my Hadoop cluster running on my laptop, but it's not a real cluster. So we'll go on out to either Hortonworks or Cloudera, and either your own cluster if you happen to have a cluster lying around, or else you can go out to AWS and sign up. And both Hortonworks and Cloudera have really easy tutorials of how to set up a cluster with HBase on it. And now, how are we going to get Kiji installed? Because it doesn't come in the default installation. Well, we can just go back here and SSH onto our cluster and into any edge node. And once more, all we have to do is just, this time instead of clicking a download button, we just wget, and you have to reset 4 variable names via export. So that's about 4 Linux commands, easy peasy. And then, what do we have to do next? Nothing. We're golden. We're flying through the air. So at the heart, so in conclusion, Kiji contains the components to allow engineers and data scientists to store this data in an entity-centric model, to build and train ML models, and Bento Box allows developers to try out Hadoop and all of its friends, both locally and then easily to take those jobs that you wrote locally and move them up to the cluster and start running them at scale. Thanks for listening, and I'm at WibiData.